Back, we are going to connect geometry back to algebra again, and I'm going to take you back in time just a little bit when we did systems of equations and we used substitution and elimination. Of course, you guys know that elimination is my absolute favorite. I don't always use it, and in fact, in example 1, I'm going to deviate from what your book shows you and do it a little bit differently because I think my way is a little bit easier. As you can see, they've given you some steps. Write the system so that the like terms are under each other. Eliminate one of the variables. Substitute that value into one of the original equations and solve for the other variable. And then write your answer as an ordered pair. Check your solution. I would check them in both equations because if it doesn't work in both equations, then that's not your solution. All right, so example 1 gives us a figure. You can see our figure right here. We have an X shape, and we have one of our angles is 90 degrees. So if one of those is 90 degrees, then they're all 90 degrees, okay? Because if you look at it as a line here, this is a straight line. So if you just look, just ignore this part right now, and just look above that line where I just drew, you can see that the linear pair would be that 6x minus 2y degrees. That has to equal 90, okay? Has to. There's no exception to that, okay? All right, let me pull out my eraser here. And let's refocus on the bottom here where the other angle is. So here's our line again, okay? And I'm going to ignore that part. So we already know that if this is 90 and this is 90, then these two also have to be 90 as well, okay? Because they form a straight line. These two are next to each other. They have to form 180 degrees here and here, here and here, here and here, here and here, okay? So what I'm trying to get you to understand is these angles are equal to 90 degrees is what I'm trying to get you to see, okay? Now you can go ahead and just launch into elimination. You could, I've lined up my like terms, my x's are on top of each other, my y's are on top of each other, my 90s are on top of each other, okay? Because I have opposite numbers here, opposite numbers when you add will eliminate. So yeah, you could draw a line under here and add these two equations together, eliminating the y's. You can do it that way. And I'll go ahead and demonstrate it the rest of the way to show you that that's exactly what will happen. Divide each side by 9, and it looks like x is 20. Okay? Now what you're going to do is you're going to pick one of the original equations, either the top one or the bottom one here, and you're going to plug your 20 back in for x. So you can do 6 times 20, there's your 6x, minus 2y is equal to 90. And you've got 6 times 20 is 120. Okay, and then we'll take away 120 from each side, just like this. And we've got negative 2y is equal to, it looks like negative 30. Divide each side by negative 2. And y is positive 15. And we're going to write our answer as an ordered pair, just like this. And of course, I would, if I were you, take your calculator out and check your answer. Make sure it works in the top equation as well as the bottom equation. And if that's the case, then that is your solution. Okay? So it's a little bit of a connection here. Now that's using elimination. You could have substituted. And the way you could have done that, actually, no, we're not going to substitute here. I changed my mind. Forgive me, we're not going to substitute. Elimination is the perfect thing to do here. So, so I would encourage you to always check your solution. And let's flip the page. Let's get to our next one here. Example 2, solve for x and y. And so what we have here is a pretty neat figure. I want to talk to you about some things. We've already learned the vertical angles theorem. And what that means is, you know, when you form your x, 72 is not adjacent to 2x plus 4y degrees. And so that means they're going to be equal in size. So you're going to create an equation right here where they are equal, okay? Your linear pair theorem just means then by default the other set of vertical angles are also going to be equal, but you don't know what that measurement is. So you have to look at it this way. Here's your line, okay? There's your line. Look to the left of it. Do you see how 72 plus this unknown amount, unknown degrees, forms a straight line? 72 plus what gives you 180 degrees. And so you're going to do some pretty basic math here to find out what that missing angle measure is. So it looks like 108 degrees, which they have that here already, but I wanted to make sure I showed you how to do that. Okay, now this is not like the other ones because at least in the other example, remember to eliminate, you have to have opposite numbers or at least the same number. Opposite numbers, you would add the two equations together. Same numbers if you wish to subtract. We don't have either one. I've got a 2x, a 4y, a 5x, and a 2y. So it's really up to you to decide, well, what variable looks easier to eliminate? What variable would take maybe some lower numbers to change? And I would advise you to change this bottom one, and let's eliminate the y's. So how could I make 2y become either positive 4y or negative 4y? And you either would multiply by negative 2 or positive 2 on the bottom there. Now, because I like to add my equations, I need opposite signs. I already have a positive 4y up top. I'm going to go ahead and do negative 4y down bottom. So I'm going to have to multiply by negative 2. That means you have to distribute it to every part of that equation. So I'm going to rewrite the top one. There it is. The bottom one, negative 2 times 5. That's negative 10x. Negative 2 times positive 2. That's negative 4y. Negative 2 times 108. Negative 216. Is that right? Does that look right to you guys? Yep. All right. So now what I want to do, because I have opposite numbers in front of my y's, I'm going to add these two equations together. Now this sign in front of my 10x is the sign of 10x. It's negative 10x. That doesn't mean that's what I do to the whole equation. I don't subtract the whole thing. That's just the sign of that particular term. So what I want to do is add the two equations together. 2 plus negative 10, that's negative 8. Positive 4 plus a negative 4, they're gone. And then 72 plus negative 216, might need a little calculator here to speed you up. That's negative 144. Excellent. Okay, then just divide each side by negative 8. And x is going to end up equaling, it looks like 18. And double check that in your calculator, of course, but that's what it looks like. So once you have x, you can easily find y. I'm just going to pick one of the other equations. I think I'm just going to go back with the top one. It's got some lower numbers in it. That works for me. I'm going to plug in my x. I'm going to do 2 times 18 plus 4y equals 72. 2 times 18 is 36. Okay. Take away 36 from each side. And then I've got 4y equals 36. Finally, divide by 4, and y is 9. So to make these two equations equal, x has to be 18 and y has to be 9. You want to double check that and verify in both equations before you totally box that in and say, yeah, that's my answer. There's a couple for you to try on the bottom of page 153 in your book. And I don't know if I've assigned that for homework or not, or if we're going to wait and do that in class the next day, but that's what we'll practice, is applying the system of equations to some of the geometry we've already learned, specifically vertical angles and linear pairs, and kind of pulling in this geometry and seeing if we can figure some of this stuff out. All right, if you have any questions, bring those to class tomorrow.